Hello, folks. This is my attempt to provide a mini lecture on dictionaries. So forgive me if there's a little start and stop. This is my first recorded kind of flipped lecture recording, and so there might be some haltingness to the presentation today. So a dictionary is a mapping. And what's the mapping between? It's between keys and values. Right? Mappings really come from the math idea of a function. And so somewhere in your algebra days, you should have learned that a function essentially maps from values in a domain to values in a range. Now, one of the key aspects of being a function or a mapping in the sense of a Python dictionary is that given a key, or in the functional sense, an element of the domain, there is exactly one mapping. Okay, what does that mean? I'm going to borrow from a Google search that includes domain, range, and function. All right? And so I want you to focus on the picture right here, okay? And we see that this is a function that has the x as the domain and the y, or the f of x, as the range, right? And so if I determine a particular value for x, I can always go to that value on the x-axis and get to the value on the y-axis, the f of x, right? Put another way, if we think about our domain and our range as sets, I can call D the set of elements that are part of my domain, and R the set of elements that are part of my range. And so anytime I can define a D in this set, there's always going to be some place that it maps to here. All right, so there's no such thing as a dot over here in the domain that doesn't have an element in the range. But it is perfectly legal for something like this, that two different elements in the domain can map to the same value, if you will, in the range. All right. What is not allowed would be something like this green line here. This green line here would be saying that this particular element of the domain maps to two different things in the range. That's the thing that is precluded by this idea of a function or a mapping or a dictionary, as it turns out. Okay? So with that as a basic idea, let's go to a Jupyter notebook. Now, along with this video, I'm going to give you kind of this same Jupyter notebook that will allow you to follow along and do exactly the same things that I'm going to do. For our example in this case, what I want is to be able to create and build a dictionary and to use a dictionary accumulator pattern to do that. We know from list accumulation, both in our book and in Dr. Havel's book, that list accumulation, we start with an empty list, and then each time we iterate through a loop, we add a new thing to the list. then iterate again, we add another thing to the list so that the list builds up step by step. We start empty and we add something with each iteration through the loop. Okay? So a dictionary accumulation is really quite similar. And so we need to start with an empty dictionary, and then for each thing that we want to process, we're going to accumulate into the dictionary. Frequencies are a precise term used for saying how many of a certain thing appears. So if we take a look at the list L1 here, right, we have A, B, A, C, D, C, A, E. Our goal in this tutorial is to create a dictionary such that the key or the element of the domain for A maps to an integer that says how many times does A appear. Now we can by inspection look at L1 and say A appears 3 times. Okay. B appears once, C appears twice, D appears once, and E appears once. Right? So by the end of a dictionary accumulation, we should have a dictionary where each of those unique elements in L1, A, B, C, D, and E, have keys and they map to integers. Just to help us out, I'm saying what some of the most common methods are for operating on dictionaries. So hopefully we remember from our CS1 that a begin brace and end brace is a way to create a brand new dictionary. Right? It's not referred to by any other Python variable. And I can put on the inside, in between those curly braces, the contents of that dictionary. The other most common thing that we do with dictionaries is that we access elements in them. Right? And so we use square brackets, not curly braces, square brackets to access a dictionary. All right, so given a dictionary, if I put square brackets after the name of the dictionary, I'm saying I want to access. We use these access operators, the square brackets, in 2 different ways. If I use it in an expression, say in a conditional or on the right-hand side of an assignment, then I put the key inside the square brackets and it gives me the value associated with that key. If, on the other hand, I use the square brackets as part of an expression on the left-hand side of an assignment, then I am going to assign or update the dictionary with a new value. So the left-hand side specifies which key is getting updated with a value, and the right-hand side says what that value should be. Once we have a dictionary that has some values in it, we often want to say, given a key and a dictionary, does that key appear in the dictionary? Or does that key not appear in the dictionary? And so we use the keywords in and not in, along with a value for a key and a dictionary. The value for the key comes before the in, and the dictionary comes after the in, so that it's a little bit English readable. And gives me back a Boolean that says whether or not that key is in the dictionary. The 3 most common methods, right? Every time we've got an object and an instance of an object, and a dictionary is an object, anytime we've got one of those, we can use .keys, .items, .values as methods that operate on that dictionary. And keys gets a set of keys in the dictionary. Items gets the key value pairs in the dictionary, and values gets the set of values in the dictionary. There's a lot more to go on than that, but these are the basic methods and operators that we're going to need in order to work with dictionaries in this class. See the note bene. Note bene means to note well. It comes from the Latin. There is no guaranteed order on the elements in a dictionary. So just because I put things in a dictionary in a particular order, doesn't matter if I take a look at the keys in the dictionary, they could appear in an arbitrary order, right? It is not based on, the strings. If strings are my keys for the dictionary, then that may or may not be the order in which I get things out of a dictionary. So our code has to be kind of order independent when we process a dictionary. Okay, so the keys themselves, let me just go back to my whiteboard for just a second. The keys can be integers, they can be strings, they could be float values, they could even be tuples. The thing that all of these have in common is that they are immutable. That means that once they have a value, that value doesn't change. Now, I might have a variable that has a particular value, and that variable has a value that might be an integer that can change, but the integer itself doesn't change. Okay? Whereas the range or the value side of a dictionary can really be anything. So in particular, the data type associated with the values in a dictionary could be any of these same scalars, integers, strings, floats, tuples. They could even be Boolean, true, false values. They could be the special value called none. But they can also be lists, dictionaries, or objects of any type, like our turtle objects, for instance. All right, so it's very powerful for me to be able to define a set of keys and have them map to anything, because then the key allows me to get back at that thing, no matter how complex that thing is. All right, so now let's go back to our example here, and we want to write the code to process that list L1, and we want to create a frequency dictionary. First step in dictionary accumulation, just like in the accumulation in a list, is I've got to start with an empty one of these things. So we'll say that D is equal to curly braces to give myself an empty dictionary to start from. Now I want to process the elements in a list, and so a for loop seems like the right construct for that. For I'll call it element in L1. Each time we go through this loop here inside of the body of the loop, the variable element is going to be associated with the first element in L1 on the first iteration of the list, the second element of L1 on the second iteration of the list, and so forth until I get to that last E, the last element of L1 on the last iteration of this for loop. Okay, so let's just start by doing a print of element, just so that we are happy that that loop is performing exactly as we want. Okay, so the key in building a frequency is that on each element, I've got one of two possibilities. Either that element is already in the dictionary, in which case I'm encountering it for a second or third or fourth time, and I want to increment the number of times I've seen that element, or I'm encountering it for the first time. And so we're going to have an if statement that branches on those two possibilities. Either I've seen this element in the dictionary before and added it to the dictionary, or I have not. All right, so if element is in D, so we are using that operator in, I'm specifying a value that is going to be a key and asking, does that exist in the dictionary? If that's the case, then I'm not sure how many times I've seen before, but if we assume that the dictionary has the number of times that I've seen before this, our job is just to add 1 to that. And so we're going to say that D sub element, we're using the access operator on the left-hand side of an assignment, is going to get updated with D sub element plus 1. Right? So relative to our access operator methods, we're actually seeing both. We're using an expression to obtain a value given a key. Given the value element as a key, we can get the current value of D sub element. Then we add 1 to it, and now I've got a new value. And then we're going to put it on the left-hand side of an assignment and update the value. Okay, so we've seen an example of in, and we've seen an example of creation of an empty, and we've seen the access operator used on the right-hand side in an expression, and on the left-hand side to update the dictionary. That's one of the reasons why I like this frequency example, is it gives a lot of these operators a chance to be exercised. Sometimes the key in working with dictionary accumulation is the else part. It's almost like the base case in recursion. Sometimes thinking about what do I do in kind of that simplest case, in this case, what do I do if this element has not been seen? It's the first time that I've seen it. Well, I've got to put an element into the dictionary, and I've got to record that this is the first time that I've seen it. Since the values for this particular example are integers, I want the value here to be 1 to record this as my first instance of seeing element in the list L1 that I'm processing. So let's just print D after this is over and run this and see what we get. I've got the dictionary that I was hoping for. A maps to 3, B maps to 1, C maps to 2, D maps to 1, and E maps to 1. And if we take a look at our original list, that is indeed the frequencies of the elements there. So we have just successfully done dictionary accumulation. Now, I really like this code, so we're going to go ahead and copy everything except the print. And another technique I like for helping students to visualize and understand how code is operating is to use Python Tutor. So Python Tutor allows me to type in any code that I like, and it will give me a visualization of the steps that I'm taking as I exercise that code. Right? And so I want to do that with our dictionary accumulation in order to build your intuition on how dictionaries work and the operators that we're illustrating in this dictionary accumulation. Okay, so now that I've got the code in to Python Tutor, we're going to say we want to visualize the execution. And let me make that just a little bit bigger. On the left, you see the code. You're going to see a red arrow here that's showing me what line of the code am I at? What am I about to execute? There's even a legend down here that says the next line to execute is given by the red, and the line that just executed is going to be given by the green. That allows us to understand in the source code itself kind of where we are and where we just were. Right? The buttons here allow us to walk through. So I first do a next, and what do we see? I need to make that a little smaller so that you can really see it. I see that the name L1, because of that assignment, is associated with, through this arrow right here, a list with indices 0 through 7, and whose values are the A, B, A, C, D, C, A, E. So this should match your intuition of what a list looks like. Right? Now we create an empty dictionary. And sure enough, in our global namespace, we now have D associated with an empty dictionary. Now we're going to go through our loop for element in L1. And knowing how for loops work, element will first get the value of the first element in the list, and we see that here. Here's element associated with the string A. And now we're going into the if statement. It's asking the question, is A in the dictionary? It's an empty dictionary. The answer to that's no. So we're going to go to the else, where we're going to take the value 1 and associate that or put it into the dictionary with the key of element, which is A. There we are. Now our dictionary has one thing in it where A is mapping to 1. Second time through, we're getting a B. So that's going to operate the same way that the A did. It wasn't in there to begin with, and it's going to associate B with 1. Now the third time through, we're getting A again. So that's going to exercise this line 7 in the source code because element is in D, and it's going to compute D sub element plus 1. So D is my dictionary, element is A, and so D sub element right here is giving me the value 1, and I'm going to add 1 to it. And then update D sub element with that. That's how that got to 2. Now I'm going to go to the third element, C, and so forth through. All right, so we can step at a time. In that case, I was actually kind of vectoring to the update operations. So hopefully that gives you a sense of what dictionaries and the operators of in and using the square brackets to access elements do. Now if we go back to our example, what I'm going to do here is create a new view for the notebook. Let's kind of go up and down. All right, one of the things we can do with in Jupyter Lab is that I can up here have part of the notebook, and by splitting the view, I can work with it down here. We know that D has our dictionary, but let's try a couple of these other methods just so that we get a feel for how they work. D is the name of the dictionary, and so when I invoke a method, I name the object, and then the first example is d.keys. And I can see that I get a set of dictionary keys A, B, C, D, E, the set of unique values that came from L1 that are the set of keys in my dictionary D. Now that doesn't look like a list. If I want to create something that looks like a list, I can say list of d.keys. If I syntactically do it right with the parens because it's a method. The other thing I can do is I can use d.keys as the sequence for a for loop. So for instance, I could say for key in d.keys, print d sub key, and that would be a way to print the set of values in the dictionary, 31211. Now that's not terribly useful because that print doesn't tell me what key it's associated with. I could make that a little bit more explicit and say print both key and d sub key, and now I've got the mapping in a kind of table form. Dot items is like dot keys, but instead of just giving me the keys, it gives me both the key and the value. All right, and so let's do it by itself. So the values are going to be A mapping to 3, which is represented as a tuple, a 2-tuple in particular. So items is always going to give me the pairs of a key and a value kind of bracketed together with the parens as a tuple. All right, there's The B is a tuple, C is a tuple, D is a tuple, E is a tuple. If I did that without the list, I can see that I get dict items, and the list allows me to kind of listify it. Now, the nice thing about using items is that I can break the tuple apart into its key and its value components thusly, right? Each time through the loop, when we iterate, I'm going to have another tuple, and the first element in that tuple is going to get assigned to key, and the second item in that tuple is going to get assigned to value for the duration of the body of the loop. The print looks the same, but the composition of the for loop is slightly different. And the last method that I have here is d.values, the values method, and that gives me the set of values in the dictionary, 31211. Now note that 1 is repeated. That's because it's a value more than one time in the dictionary. All right, so I can get the keys by themselves, I can get the values by themselves, I can get the key value pairs as tuples using those three methods. And with that set of fundamentals, that's enough for us to work to build much larger and more interesting things. As we're going to see in class, we're going to have values that are lists. We're going to have values that are dictionaries. And we can make the value arbitrarily complex, and that's part of what allows us to define trees and two-dimensional data structures. And we'll see that starting through the next week in Intro to Data Systems. All right, that's my whirlwind tour of dictionaries. I hope it proved helpful to folks that wanted to kind of reinforce their knowledge on it. Thank you for listening.